let me show you how I built my own 12 frame honey extractor. Through this video I'm going to go through and really break down each of the steps that I went through to make the project, and basically make it with you throughout the video. Now before we start, for this build I had access to a full range of workshop machinery. So I had use of a lathe, I had a TIG welder, I had pyramid roller. I had basically full access to workshop machinery, and some of those machines has really made it easier for me to build this project. It is next level DIY, a little bit bigger than your backyard job, but hopefully you'll find it useful and you'll be able to go away from it and build your own extractor. So the first part of my build was finding a drum. I had a few options. I wanted to either look for a second-hand drum that I could convert, or I was going to make a brand new one out of stainless steel. Now I picked this drum up from a scrapyard aluminium tank for $30. The stainless steel equivalent, if I had rolled my own, would have been about $200 in material. So I was very happy with finding this. From what I did with it, basically I cut the top off it. I plugged up any holes with some aluminium and TIG welded that, and then I just added a ring to the top of stainless steel angle, like so, and that's just given it a bit more rigidity, and you know, kept the shape nice and round as I continue to build on it. So I've made the top and the bottom bracket that's going to hold the motor and also the main shaft. It's been made out of stainless, fabricated it, and then put the nut sets in, and we've got these bearings here with a collar. It's a 20mm hole. It's going to run a 20mm shaft down through the center. Once they're bolted on, we'll put the nut sets in the end here as well, and that's going to then fix to the main barrel after that. So at the stage now where I've mounted the bottom bracket, and for that all I did was just a couple of rivets on the outside. That was a bit of a pain to try and get that nice and level and square, but we got it in. I then proceeded to put the top one in, trying to ensure that the axle was nice and square, and for that I also need to notch out here around the stainless steel as well. For this top piece I used inset nuts, so they're rivet nuts, and that's bolted on like so. With the idea that this will need to come off to be able to put the cage in. I also want the whole thing to be able to come apart as well for serviceability. So at this stage I've fixed the legs on, put 3 legs on, and I've used the rivet nuts with 3 stainless steel bolts going through into the rivet nuts which are inside like so. I probably will end up capping the tops of these, just to finish it off a little bit. Now one of the other things I wanted wheels on it. A lot of the commercial ones that I've seen, or the ones available for purchase, don't have any wheels, and this thing is getting heavier and heavier as we go. So what I've done is, the feet are still on the ground, and I've mounted these wheels, and you can see just off the ground by about 3mm. In hindsight, probably could have gotten a little bit closer to the ground, maybe 2mm off. Just got enough clearance there. And then it's a stainless steel bracket with the idea we can now tilt that like so and wheel it around the room to put it back into storage. So that came out really well. Really happy with the way that looks, the way it functions, and as you can see, the pivot point, or the center of the axle for the wheel, is just behind the 2 legs. So as it tilts over, it picks up that wheel like so, like that, and the legs come off, which is spot on, exactly what I want it to be able to do. And obviously when you're using the extractor, it's still sitting nice and stable on the ground for spinning. So I've drawn up the internals of the honey extractor. And this has got the full cage and also placement for the actual frames to sit as well, and I've worked out I can get about 8 frames into the extractor. here. What I'm doing now is I'm just cutting it out in the laser cutter, and this will act as my template for rolling all the rings with stainless steel, and also placement of all the baskets as well to sit the actual frames into. Next step from here will be to make up the cage. Okay, so I've rolled the bottom part of the cage. I've grabbed the axle back out of the extractor and placed it in a hole in the centre, and there's about a 50mm gap underneath this timber template. Like so, I've just jacked it up a little bit so that the axle comes through, and so it'll still sit in the bottom bearings in the extractor. I've cut the 4 pieces of so this is all 10mm rod, and I've placed it all on the jig, lining up nicely. I managed to get the ring a little bit bigger than what I'd actually drawn it up on the template. As I was rolling it, I managed to get a slightly bigger ring fitting inside the extractor, which is good, because what it might mean is that instead of having 8 frames, I might actually be able to get 12 in there, I'm thinking, but I'll test that as we get closer. So I'll go in and I'll weld that up, and then I've got this second ring to come in and sit on top, and the frames will sit on top of that with some little bits of flat bar bent up just to hold the bottoms of the frames. Time for a test run. Good clearance around the sides. Now finish welding up the rest. So at this stage I've finished building the inside cage, so I've put a little bracket up top here to hold the frames, and then down the bottom I've put some more. Now I did manage to get 12 frames in, which is great. As you can see here, there's 2 frames in there. I've got a third one there quite comfortably, and so far so good. So the next step from here will be mounting the motor, and then finishing off the electrical. So I might actually give it a good clean up before I get to that stage though, and just start assembling it as I go. Alright, so since welding up the frames, I put a little D on the bottom for the bottom of the frame to sit in like so, and I cleaned up all my welds. Before I put the cage in, I went through and I cleaned the drum, and I cleaned up everything basically, and I've assembled it now as it's going to be. So I've taken the stainless cover off up here, come through, I put the honey gate in like so. In hindsight, so basically I'm operating from here, this is the middle, and so I wanted the honey out of the way when it was pouring so I didn't knock the bucket. But in hindsight, when I'm to get the very bottom of that honey out of the drum, I'm going to have to tilt it. So, and you can see I really should have put it around about here so it's easy to tilt. Instead I'm going to have to try and tilt it with a slight angle. I've also capped off the tops of the stainless, which looks a lot better, and just cleaned everything up. I'm now at the stage where I can mount the motor. It's coming along really well, it spins beautifully. Really happy with that. Now onto the motor, which I've taken from a treadmill. It came with a bracket, but I took that bracket off for mounting because it was quite big and clunky, and I've used the 2 holes that it came with, and I've welded up this stainless steel bracket which comes up over the top and then it gets bolted through like so. I use rivet nuts to fix it through to the stainless cross member there. What I've done here is the motor had a keyway, so I've just threaded, drilled and threaded 3 grub screws on the main axle, and they bite down into the keyway shaft. It should be fine for this application. If it came under a heavy load, they might shear, but to be honest with you, I think it's been more than fine for what we're doing here today. And so that's all mounted like so. And then so on to wiring up the motor. Okay. In many situations, the treadmills come with a circuit board called the MC60, which are quite easy to wire up. You just need to add a potentiometer onto that circuit board, and then you're able to get the variable speed. But of course with this one it didn't come with that sort of circuit board. So what I need to do is I purchased a 10,000 watt AC speed controller off eBay. It cost about $22. And then from there I also bought a 50 amp bridge rectifier. And so what that bridge rectifier does is it converts the AC power to a DC power, which is what the motor needs. And then from there we've got it operational. We've managed to get it running. If you want to see a more detailed explanation of how the DC power supply works, then you can click on one of my other videos in my collection, and I'll go into much more detail on how I wired it all up. That's all done. The last stage of the build has been to tidy up the wiring and just run that neatly underneath through the box, and then to also add the acrylic lid. Put a rare earth magnet just there, so we can lift that up, hold its place, and frames come in and out like so. And that's it, that's the end of the build. If it's going to change anything, I'll probably run the motor off a pulley system to reduce the RPM, which would then give me a bigger range of movement with the potentiometer. That's one thing I'll change. The only other slight thing I would change would be putting that tap in the center of the two legs, so that when I tilt it over, it's going to be pouring it all out properly. Other than that, I'm super happy with the build. It came in at under $300. I haven't quite priced up the stainless yet though. The tank was $30. The electrical components came in at about $30 as well, maybe $35. Motor was free. I just need to cost up the acrylic and the stainless steel that I use, which would have come in, you know, under $200 quite comfortably. So for a total of $300, I've built myself a 12 frame extractor. Super happy. Hope you found this useful. Feel free to give any comments and let me know what you think of the build, or things that perhaps I could have done better, you know, during the process. But thanks for watching.